Welcome everyone to the AI Research Bites. This series of short and informative talks showcase cutting-edge research work from ServiceNow's AI research team. The AI Research Bites are open to all, especially those interested in keeping up with the fast-paced AI research community. Today's session features a 15-minute talk from Joao Monteiro on evaluating the capabilities of LLMs to leverage user-provided content and answer questions. It will be followed by a 10-minute Q&A. And as usual, please use Zoom's Q&A button at the bottom of your screen. Joao is a research scientist within the multimodal foundation models team at ServiceNow. What a mouthful. His research has a focus on data-efficient learning strategies across multiple settings, including information retrieval and autoregressive generative modeling. His research interests also span robust learning setting, enabling models to generalize to unseen conditions during training, and efficient inference methods. Up to you, Joao.
Thanks for the intro. Thanks everyone for joining. I'll talk a little bit about RepLiQA. RepLiQA is a robust benchmark that we recently released for question answering tasks. This is joint work with Pierre-André, Etienne, Sai, Valentina, David, Nicolas, Chris Paul, and Perus. Before I start, let me just highlight that all the content that we represented here is to the best of my knowledge. I'll start by talking a little bit about the setting we are concerned with in this project. Provide some motivation, some limitations in the existing benchmarks that we seek to address. And then I'll talk a little bit about RepLiQA, which is a data set that we released recently to address those limitations. And then I'll show some results covering state-of-the-art language models on top of RepLiQA and some interesting findings given by those results. Let me just give an example to introduce this setting that we are concerned with in this project. So we want to ask questions to a language model about some user-provided content. So as you can see in this example, the user is asking a language model about a network issue that they have, and they provided the language model with some context, like incident logs and some documentation. And in an ideal situation, the language model would be able to kind of consult those documentations and then reply correctly. Hey, this is a software issue. You should reboot and update the driver. So that's a very typical, very common use case, and that's the behavior that we would expect for a well-performing language model. But that's not always what we observe because of the model memory, right? Like, so the language models are trained on vast amounts of data, and they memorize some of the knowledge that they were trained with. And that memory confounds generation. So it's never clear if the model is generating content based solely on the provided context. Sometimes it mixes up some of its training memory into generation. So we could have a situation so that the model completely ignores user-provided content. So it completely ignores the incident logs, it ignores the documentation, it just looks at its own memory and replies incorrectly that it's a hardware issue rather than a software issue, and asks for the user to replace the router, which is a much drastic solution than just rebooting. Right, so this is the behavior that we want to avoid. We ideally want models to be able to look up user content and use that information reliably. Especially in the enterprise, right? Like, so we want to deploy models in such a way that if we provide a company-specific information in the form of documents and I don't know what kind of content we could use, the model would actually use those contents to generate. And to enable that, we need to be able to disambiguate, like when the model is generating content based on its memory and or based on provided context. LLMs that ignore the context, they will be unreliable in production. So we need to measure for that somehow. And that's the question that we pose to ourselves in this project. So how can we test for the ability of different language models to search and actually use information that was provided by the user? We want to compare language models in terms of datability. And what we found is that the existing question answering data sets, they are confounded because they enable the use of memory to answer questions correctly. So what I mean by that is that if you look at the most popular Q&A data sets, they are typically built using information that's openly available on the web. So they cover things that are widely documented. And most likely, language models, they were trained on documents that have answers to the questions that are posed in those benchmarks. So you cannot distinguish like whether a model like can or cannot consult user-provided context because the model could answer those questions directly from memory. And yeah, so basically our conclusion from that is that we need new benchmarks. We need to somehow come up with data sets that enable testing the ability of models to look up information within user-provided content and actually use it. And to address that limitation, we introduced RepLiQA. So RepLiQA is a collection of reference documents. And each of these documents contains 5 question-answer pairs. Most importantly, all the documents in RepLiQA, they feature fictional scenarios created by human writers. So basically, all the content that's in RepLiQA is fictional, is untrue, is unfactual. So it covers non-existing things, people, places, types of food, types of music. So it covers things that don't really exist. And since those things don't exist, they cannot be documented elsewhere. So language models don't know anything about the entities that are covered in RepLiQA. So if you give a model a RepLiQA document and then you pose a question about that document, if the model answers correctly, the only way it could have done that is by being able to find the answer within the document you provided. So we can decouple memory access to context access in that case and actually measure for the ability of model to look up user context. And something else we did to further enable reliable evaluation was to split data set into 5 chunks. And we do these sequential releases. So basically, we plan to release RepLiQA in stages. There are 5 releases planned. Only the first release is available so far. And this is so that we continue providing data, fresh data that people can use to train, to evaluate new models that are trained later. So basically, we just released the RepLiQA 0 a couple months ago, and then starting in December, we plan to release a new split every quarter, so that until the half of 2025, people have fresh data that we guarantee was not part of any training set of any new model, and then they can be used to evaluate those models. So now just briefly cover the procedure that was used to build the RepLiQA. First of all, we had support from crowdsourced workers. This was somewhat a large-scale data annotation for it. And the first thing we did was to create a list of topics that we wanted to be covered. And the annotation procedure would be such that the annotator would first pick a topic, write a document on top of that topic. The document would look like, I don't know, a Wikipedia article or a news article, something familiar and natural looking. And they would use anonymized names and then fake names for things so that they don't really exist. And then they would summarize those documents and use those summaries to create question-answer pairs. There are some quality control on top of that data, so peer review and then expert review of a subsample of the data, some automated checks, and then the final result was handed to us. We performed some extra cleaning up on top and the data splitting, and released the first split, RepLiQA 0. This is one sample from the data set. As you can see, there's a topic, cybersecurity news, a summary of a document here, and then a question-answer pair. The document covers a fictitious cybersecurity event that never really happened. So if you look up the internet, like the October 15 date of 2023, there's no relevant ransomware attack of any sort. So this is completely fictitious. However, some of the entities that appear in Dataset, they are real. So if you Google Greenfield University, for instance, you will find a university with that name. It does exist. It's just not related to any ransomware attack of any sort. So it talks about a context that's completely fictitious, even though sometimes real entities will be mentioned. And if you pay attention to the questions up here, you see that those questions, they can be answered by simply looking at the document. So the document should be sufficient to enable answering the question accurately, and you shouldn't need any external source of information. Yeah, this is an example of the dataset. And just a brief overview about the dataset. It covers 17 topics, somewhat uniformly. Each document has 5 questions and pairs. And an interesting feature, in my opinion, some of the questions cannot be answered based on the reference. So we have some questions that if you read the document, you cannot answer it. And that's intentional. So we made it so that the dataset can also be used to evaluate how good models are in refusing to respond when the answers are not present. So we can also test for that. And that's a nice feature of RepLiQA, in my opinion. And now that I covered the dataset, let me just show some results. This is but a subset of what we report in the paper. In the paper, you find a lot more results. And what I wanted you to pay attention here is a huge gap that you observe between results of several language models evaluated on RepLiQA and on Trivia QA. So Trivia QA is a Q&A dataset, and we specifically focus on the split of Trivia QA that is built up on top of Wikipedia. So in the 2 cases, we give the model the same resources. So a context document, we pose a question, and then we ask for an answer. And as you can see, there is a huge gap in performance, and this is for all models that we evaluated. And it's a bunch of models. So this leads us to the conclusion that models answer questions typically relying a lot on memory. And once you remove that resource, models suffer to answer questions with accuracy. And apparently scale doesn't help much. So as you can see, like in many cases, if you increase model size, you actually degrade performance on RepLiQA. So our hypothesis is that bigger models rely even more on memory, and then scale alone doesn't seem to be a solution, at least a consistent solution to this problem, and we may need something else. And as a conclusion from this subset of the results we report in the paper, instead of the language models, they seem to be very limited in the ability to seek and use information, user-provided content. Yeah, and maybe we need some improvement in those models. And yeah, in conclusion, state-of-the-art language models don't seem to be quite good at looking up information and using it. This is what RepLiQA enabled showing, and this is not captured by common benchmarks. So in common benchmarks, models will benefit of that training memory to answer questions accurately. So we need more benchmarks like RepLiQA that completely avoid leakage of information of any kind into training. And yeah, this research also gave us like a lot of interesting research ideas that we plan to tackle in future work. I think I should mention. So for instance, what if user-provided content contradicts model memory? And should a model trust its own memory or the user? So for instance, if a user provides a document that says that the capital of France is New York, and then you ask the model, what's the capital of France? Should a model say New York or Paris? So what's the expected behavior in this case? And what if the user is an adversary? So what if the user is injecting falsehoods in the context so that the models reply incorrectly? So those are open questions that we hope will be addressed soon. And he also released a few resources that you should check out. So the data is available on Hugging Face. We also released some codes that helps manipulating the data and evaluating models on top of it. And the paper is on archive with a lot more details and a lot more results. Thank you.